Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapiens Education. So today I'm going to solve an NCERT solution for a class 12, and the chapter which I am going to cover is Magnetism and Matter. So let's go for one by one. So first of all, I will solve question number 5.1. So the first and foremost thing, most important for you, I am just telling you that you have to understand the question first of all, right? So first of all, read carefully a question. Many people doesn't read it carefully, so getting a wrong answers, right? So short bar magnet placed with its axis 30-degree with a uniform external magnetic field of 0.25 Tesla experiences a torque of a magnitude of equal to this one 4.5 into 10 power minus 2 joule. What is the magnitude of the magnetic moment of the magnet? So let us suppose there is a magnet, right? So let us suppose there is a magnet like this. So there is a bar magnet and it has been placed in an external magnetic field. So let us show me external magnetic field like this. So this is the external magnetic field, right? So this is the magnetic field B, right? And it is making an angle of 30-degree with the magnetic field. So who is making 30-degree angle? Magnet. So it is making 30-degree. So whatever data they have provided you, just put it. External magnetic field they have provided you as 0.25 Tesla. Okay. And the torque, see what will happen if you put a magnet in the magnetic field, so it will experiences a torque either this side or this side depending upon the polarity, right? So the torque they are experiencing as 4.5 into 10 to the power minus 2 joule, right? And the angle made by the magnet with the magnetic field is how much? So theta they have provided you 30-degree. Got it? What do we need to find? We need to find a magnetic moment of the magnet. Every magnet has a magnetic moment, right? So what is the magnetic moment of this magnet? We need to find this. So the basic formula we should use is equal to magnetic moment B sine theta. So torque they have provided you 4.5 into 10 to the power minus 12, and this is equal to magnetic moment into B sine theta. So this is equal to 0.25 into sine 30. So from here magnetic moment is equal to 4.5 into 10 to the power minus 12 divided by 0.25 into 1 by 2. So from here what we can infer, that is equal to 0.36 joule per Tesla. So this is our magnetic moment, right? So I hope you have understood it well. So let's proceed for next question, and the next question for us is 5.2. Before solving, just go through the question. A short bar magnet of a magnetic moment is given as 0.32 joule per Tesla, is placed in a uniform magnetic field of 0.15 Tesla. If the bar is free to rotate in the plane in the field, which orientation would correspond to its stable as well as unstable equilibrium, and what is the potential energy of the magnet in each case? So let us try to understand first of all what they have provided you, or let us draw the diagram so that you can understood, right? So let us suppose there is a bar magnet like this. Any bar magnet may be like uh, right like this, right? Okay, and there is a magnetic field around it. There is a magnetic field. It may be like this, anywhere we don't know, right? There is a magnetic field, right? This is the orientation. It doesn't have any fixed orientation. Now the thing is that what they have given you, you have to write it. So the magnetic moment of the bar magnetic moment of bar magnet, that is M is equal to 0.32 joule per Tesla. And the strength of external magnetic field, this is external magnetic field, and the strength of this one is 0.15 Tesla. If the bar is free to rotate, so let us suppose it has been hanged with someone, so it may be free to rotate, right? And which orientation would be corresponding to the stable equilibrium and unstable equilibrium? So first of all, we should talk about stable equilibrium. Stable equilibrium. So the condition for the stable equilibrium, right? So when it will be stable, when bar magnet is along the magnetic field, along the magnetic field. So it means this magnet should be like this magnet should be like this, then only it will be in this along this direction. That is, angle between magnetic field and the bar magnet is 0 degree, right? It is 0 degree, right? So I hope you have understood this one. Now what they are asking, what is the potential energy of the magnet in each case? So we can write from, in this case, potential energy. So the formula for the potential energy is what? Minus mb cos theta. So minus m means 0.32 into b is 0.15 Tesla into cos theta, that is equal to cos 0 degree. So while doing this one, so we will have minus 4.8 into 10 to the power minus 2 joule, right? So this is the potential energy when it is in stable equilibrium. Now we will talk about unstable equilibrium, right? So what is the condition for the unstable equilibrium? Unstable equilibrium. So let us suppose there is a bar magnet. This is north, this is south. And this bar magnet is making 180 degree. Angle made by bar magnet is 180 degree to the magnetic field. That is, theta is equal to 180 degree, right? If theta is equal to 180 degree, so we can say that it is in unstable equilibrium, right? So the potential energy for this case will be equal to minus mb cos 180 degree. Just put the values. So earlier we have got minus 4.8. So it will, when you calculate it, so it will become plus 4.8 into 10 to the power minus 2 joule, right? 10 to the power minus 2 joule. So this is the potential energy. So I hope you have understood this one. Sorry. Now next is your 5.3. So let's read first of all the question. A closely wound solenoid. Solenoid, I hope you all have understood this. What is solenoid? So this is a solenoid, wounding of the wire in a spiral way like this. So it is considered as a solenoid. Having a how many turns? 800 turns, and the area of the cross section is 2.4. So which area we are talking about? This area, this area of the cross section. Area of cross section is how much? 2.5 into 10 power minus 4 meter square. Carries a current of 3 ampere. So each wire is carrying a current of 3 ampere. Explain the sense in which the solenoid act as a bar magnet. So first of all, we need to understand that why this will act as a bar magnet. So first of all, you need to draw the diagram of the solenoid. So let us suppose this is a solenoid, right? This is a solenoid, right? So I hope you have studied in theoretical part, or if you have not studied, so you go to the theoretical part of our channel so that you can understand, right? If you pass a current through this, right? Let us suppose this is positive charge and this is a negative charge, and if you pass a current through it, so what will happen? We know that any current carrying conductor will create a magnetic field like this, like this, like this. So each wire will create a small magnetic field. But when we add it, so when it will add, so it will create a magnetic field like this, like this, that's like this, like this. Got it? So one you will find that one side it is coming out and one side it is going in. So going in, so if you compare it with the solid magnet, so let us suppose this is north pole and this is south pole. So field lines will originate from this one also and it will go like this. So we can say that the field lines is creating like this. Field lines are coming and going inside it. So definitely it will act, this side will act as a north pole and this side act as a south pole. So what we can write from this one is that a solenoid, a solenoid will behave as bar magnet, because in both the case magnetic field lines will come out from one side, and it will enter it will enter other side, right? So this is the way we can explain it. Now at the same time they are also asking what is the magnetic moment associated with it. They are asking what is the magnetic moment. So you know the formula for the magnetic moment is what? Magnetic moment is equal to, could you please explain me magnetic, can you guess the formula? Try to do it by your own. It is NIM. What is N? So this is N number of turns, and this is current I, and this is area. So this is area. So can we write this one in a proper way? So let us write it. 800 into current is 3 ampere into area of cross section is 2.5 into 10 to the power minus 4 meter square. Not meter square. When you cancel units, so finally it will have a different unit, that is it will have a different unit, right? So just calculate it, just pause the video, you can calculate it by yourself. So you will get 0.6 joule per Tesla as the magnetic moment, right? I hope you have understood this one. Let's go for next question, right? First of all, read this question carefully so that you can understand what they are saying. If the solenoid in exercise 5.5, so previous solenoid we are talking about, not 5.5, it is 5.3, so by it is a printing mistake, is free to turn about the vertical direction in a uniform horizontal magnetic field 0.2 is applied. What is the magnitude of the torque on a solenoid when its axis makes an angle of 30 degree with the direction of the applied field? So first of all, you need to understand that how to draw the magnetic field. So let us suppose this is magnetic field, right? This is magnetic field and this is a magnetic field, right? So the amount of magnetic field or strength of the magnetic field they have provided us as 0.25 Tesla, right? And this solenoid is uh, free to turn about a vertical direction. So let us suppose this is a vertical direction, right? This is a vertical direction, and there is a solenoid, right? And it will try to rotate in this direction like this, so about a vertical axis, right? So it's like this. If you can understand 3D figure, so like this, it's like this, right? So it is making an angle of how much theta is equal to 30 degree with the vertical axis or magnetic field, sorry, magnetic field. So the direction of magnetic field, right? What is the magnitude of the torque on the solenoid when its axis making an angle of 30 degree with the direction of the applied field? So if the angle is theta, that is equal to 30 degrees, so what is the magnitude of the torque? So torque is equal to, what is the formula for the torque? The formula for the torque is m magnetic moment of the solenoid into strength of the external magnetic field applied into sine theta, right? So I hope you have gone through the theoretical video, right? So let us put the value. What is the magnetic moment of this solenoid? So we have already done this one is 0.66. So put the value of this one 0.6 into magnetic field. Strength of the magnetic field is 0.25 Tesla into sine theta, that is sine 30. Sine 30 degree is equal to 1 by 2. So this will be equal to approximately, not approximately, equal to, this is equal to 7.5 into 10 to the power minus 2 joule. I hope you have understood this one. So this is the torque, right? This is the torque. Got it? Now let's go for next question. That is question number 5.5. So I hope you understood all the previous question.